In this video, we are going to look at solving linear equations. So when you are solving linear equations, I want you to remember your ultimate goal. Your ultimate goal is to get the variable, or the letter, on one side of the equal sign and everything else on the other. We're trying to figure out what number would go where that letter is. So you can almost even think of the letter as like a question mark. What number would go there in order to make that a true math statement? And so the equal sign tells us that the two sides are the same. It's like they're on a balance. So whatever we do to one side, we have to do to the other in order to keep the sides balanced. So for example, if we had the equation x plus 2 equals 5, this is what that visually looks like. I have an x, and I have two weights that I know equal 1 on one side. And on the other side of the equation, I have 5 weights. And maybe when I put it visually like this, you can see automatically what number or how much that x would have to weigh in order for this scale to be balanced. But what we can do is kind of continue to solve this out. So if I want to get the x on its own, I'm going to need to remove 2 of the 1's in order to get the x on its own. But now my scale is not balanced. So in order to keep it balanced, I'm going to have to remove 2 from the other side as well, which then tells me that my x must be the same as 3 1's together, or my x is equal to 3. Okay, so I want you to think of solving these equations like you would if you were on a scale and you're trying to figure out how much that letter weighs, knowing that you have to keep the scale balanced. So let's first try this with one-step problems. What do these look like for addition, subtraction, multiplying, and dividing? So in our first question here, we have an x, take away 3 equals 12. Again, what I'm trying to think in my mind is something, a question mark, something minus 3 is the same as 12. So what number would have to go where the x is in order for this sentence to make sense? Right? And so if I want to get the x by itself on the scale, I'm going to have to remove or get rid of this take away 3. And how do we get rid of a take away 3? We need to add 3. But because we want to keep both sides the same, I'm going to add 3 to both sides, which tells me that this x is the same as 15. Okay, so 15 take away 3 equals 12. Okay, let's look at the next one. If I have x plus 3 equals 12, something plus 3 equals 12. Again, if I want to get the x by itself, I need to get rid of this plus 3. And to get rid of a plus 3, I'm going to subtract 3. And again, whatever we do to one side, we have to do to the other to keep it balanced. So I get x plus 3 take away 3 equals 12 take away 3. So all together, I have x equals 9. 9 plus 3 equals 12. When I have something that looks like this, what that's telling me is x divided by 3. We can think of that fraction line as a divide. Something divided by 3 equals 12. And so if I want to get rid of this divide 3, I need to multiply by 3. So again, we're going to multiply both sides of the equation, and I'm left with x equals 36. So 36 divided by 3 equals 12. And finally, if I have 3x equals 12, what that's telling me is 3 times x, 3 multiply x equals 12. 3 times something equals 12. So if I want to get rid of this multiply 3, I'm going to divide both sides by 3, and so I end up with x equals 4. 3 times 4 equals 12. So let's again just take a look. If I have a subtraction, I'm going to add in order to get rid of it. And I'm going to do that to both sides. If I have an addition, I'm going to subtract from both sides. If I have division, I'm going to multiply. And if I have a multiply, I'm going to divide. What happens if there's more than one step? So if we have two-step or multi-step problems, how do we know what to do first? Well, if you remember, we have something in math that tells us what order to do operations in, and this is the order of operations, also known as BEDMAS. That tells us what order to do things in. Now, when we're solving equations, we're undoing. We're trying to undo those operations. So what we're going to do is the order of operations backwards. So if we are trying to solve these, we're trying to get rid of any subtraction or addition first, then any division or multiplication, then exponents or square roots, and then brackets. And again, if we think of this in terms of a balance or a scale, so if here is my scale, here's my balance, and on this side I have 2 T blocks and a block that somehow takes away 7. And on this side, I have a block worth 9. Right? In order to figure out what T is, I'm first going to have to deal with this -7 block before I can then figure out what each T is worth. I can't divide by 2 here to figure out what each T is worth because I still have that -7 block in the way. And so we're going to undo our order of operations, getting rid of any addition or subtraction first, and then we can do multiplication or division, exponents, and then brackets. So let's look at 2t minus 7 equals 9, like I've drawn here on the scale. The first thing, I have a multiply 2 and a -7 happening to my t, right? My t is being multiplied by 2 and then subtracted 7. And so I have a multiply and a subtract. I'm going to get rid of this subtract 7 first. Okay, so to get rid of a subtract 7, we're going to add 7 to each side. So I'm left with 2t on this side and 16 on this side. So I've gotten rid of that -7, and I'm now left with 2t equals 16, which is just like our one-step problems. I now want to get rid of this multiply 2, so I'm going to divide each side by 2, and I end up with t equals 8. Okay, and we can always check by doing some substitution. 2 times 8 minus 7. We want this to equal out to 9. So I get 16 minus 7, which does in fact equal 9. So I know that I did it right. Okay, here are 2 more questions I'd like you to try. Pause the video, try them out, and then start it up again when you're ready. Okay, let's look at question number 2. If I'm looking at what is happening to my x is being multiplied by a 4 and subtracting a 10. And so which one am I going to do first, my multiply or my subtract? I want to get rid of this subtraction first before I can deal with the 4 I'm multiplying the x. So to get rid of a subtract 10, I'm going to add 10 to both sides. And so I end up with 4x equals 12. And now I have my one-step problem. I can get rid of this multiply 4, so I'm going to divide by 4 on each side, and I get x equals 3. And again, we can check by substituting it back in, and we're hoping our answer comes out to be 2. So I get 12 minus 10, which does in fact equal 2, so we know we did it right. And question number 3, Same process, but we've put the x on the other side, but the process is still the same. I'm looking at what is happening to my x. It's having a multiply 5 and a subtract 10. Right? So I'm going to deal with the subtract 10 first. I'm going to add 10 to both sides. So on this side I end up with 20, and on this side I have my 5x. And now I can deal with my multiply 5 by dividing by 5. And on this side, I end up with 4 equals x. And again, we can check. Negative 10 plus 5 times 4. We want this to equal out to 10. So minus 10 plus 20 does in fact equal 10. So we know we did it right. What happens if we have variables, we have an x, on both sides of our equal sign, or we have more than one within our equation? What do we do? Well, what we need to do is to collect our like terms so we end up with only one x. We only want one in order to solve it out. And so we need to figure out how to collect our like terms together so we only have one x to deal with. Now again, remember, our ultimate goal is to get the variable on one side, all the numbers on the other. It doesn't matter which side of the equation. As you saw in our previous example, it doesn't matter which side the x or the variable is on, but we need to get them all on the same side. So first, let's see if there's anything we can do to simplify this equation to collect like terms before we start trying to move things about. So on the one side of the equal sign, we have an x minus 7. I can't really simplify that side anymore. But on the other, I have a bracket I can expand, and I can collect some like terms. So let's expand the bracket first. Minus 1 times 6x gets us a minus 6x. And negative 1 times negative 8 gets us a plus 8. And now I can collect those x's together, giving me negative 3x plus 8. Okay, so now each side of the equal sign is as simple as I can get it. I need to focus on getting my x's onto the same side. And we can do this by thinking about how we get rid of the x on that side. Again, it doesn't matter. You pick a side. The more you do, the more strategy you'll start to come up with in terms of which side you want to work with. But either way, you'll get the right answer. Just one side might be a little bit more work for you. I'm going to work on putting my x on the left-hand side because it has the positive x. So I'm going to focus on keeping that x, and I'm going to try and get rid of the minus 3x on the right-hand side. So to get rid of a minus 3x, I'm going to add 3x. Again, we have to add it to both. And so you'll notice what you end up doing is kind of moving it over to the other side, right, by getting rid of it. And so on this side, I end up with a 4x. I have an x plus a 3x minus 7. And on the right-hand side, I'm left with just an 8. So you'll notice that by getting rid of the x on the right-hand side, I end up almost moving it over to the left-hand side. And now my equation looks the same as it did in our two-step problems. So I can solve it out the same. I have my x is being multiplied by a 4 and subtract a 7. I'm going to deal with the subtraction first by adding 7 to both sides. So I get 4x equals 15. And then I'm going to get rid of this multiply 4 by dividing by 4. And I get x equals 15 over 4. Notice it didn't give me a whole number, so I'm going to keep it as a fraction. And then I'm going to put that fraction as a mixed number to simplify it as much as possible without having to go to a decimal that's going to give me maybe a funky decimal point. And so 4 goes into 15 3 times fully, which gets us to 12, which leaves us 3 out of 4 left over. So I've put it into a mixed number. Yeah, you could also write 3.75. It depends on whether you want your answer as a fraction or a decimal. Okay, so I want you to try question 2 and question 3. Pause the video and then start it up again when you're ready. Okay, so the first thing I'm going to do again is try and simplify each side of the equation before I start trying to move anything about. And so I'm going to expand the bracket on the left-hand side. So this -6 is going to apply to the 2 and the minus 3t. So I get minus 12, and then -6 times -3 is plus 18t. And t minus 5, that's as simple as I can get it on that side. On the left-hand side, I'm going to look at collecting like terms, which in this case, my 3 and my 12 can be combined. So 3 minus 12 gets us a minus 9 plus 18t equals t minus 5. So I've simplified each of the sides of the equation as much as I possibly can before I start trying to move things around. So my next step is to get rid of a t on one of the sides, and I'm going to keep the t on the left-hand side because it's a bigger positive number. And so I'm going to work on getting rid of the t on this side. So to do that, I'm going to subtract a t from both sides. So I get -9 plus 17t equals -5. Don't forget the negative in front of the 5 there. And now it's just like our two-step problems we looked at before. I'm going to get rid of this -9 first because we deal with additions and subtractions first. So I'm going to add 9 to both sides, and I get 17t equals 4. And now I can get rid of this times 17 by dividing by 17. And again, it's going to give me kind of a funky decimal, so I'm going to leave it as 4 over 17. And it's not an improper fraction, so I can't put it as a mixed number. I don't think there's anything that goes into 4 and 17, so it's as simplified as I can get it. Okay, question number 3. So in this one, each side of the equation is as simplified as I can get it. And so normally our next step is to get rid of an x on one of the sides, which you can still do that, but I think what would make this question actually easier is trying to get rid of the fraction, one of the fractions. And so the easiest fraction I can get rid of here is this divide 8. I can get rid of this divide 8 in order to simplify that side of the equation even more. So I'm going to times by 8 on both sides. And so on this side, I'm left with x. And on this side, I'm left with 3 times 8, which is 24, x over 4, which I can actually simplify even further into saying 6x. 24 divided by 4 gets us 6. And now I can try and get rid of an x on one side. I'm going to keep the x on the right-hand side because it's a higher positive x. So I'm going to subtract x. And so I end up with 0 equals 5x. And now I can divide by 5. And I end up with 0 equals x. And again, we can check this. Doing 0 over 8 equals 3 times 0 over 4. We get 0 equals 0 over 4, or 0 equals 0. And so we know it's worked out. Let's try one more together. You're going to have x's on both sides. Each side of the equation is as simplified as I can get it, except for this divide 5, this fraction on the bottom. I don't like that. I'm going to get rid of it. And so to do that, I'm going to multiply both sides by 5. Now careful, when you multiply by 5, you need to multiply all of the terms by 5. So even though I'm multiplying 2x over 5 by 5, that doesn't mean I can ignore that plus 4. The whole side is being multiplied by 5. And so I end up having 2x, divide 5 times 5, so that just gives me 2x, plus 4 times 5 is 20. And then on the other side, I have 15x minus 175. And so I've gotten rid of that fraction by making everything 5 times bigger. And now I can work on getting rid of the x on one side. I'm going to keep the 15x because it's a bigger positive number. So I'm going to look at getting rid of this 2x. So I'm going to minus 2x. And I'm left with 20. And then 13x minus 175. And now I want to get rid of this minus 175. I'm going to add 175. So I get 195 equals 13x. And now I'm going to get rid of this multiply 13 by dividing by 13. And I end up with 15 equals x. And again, we can check by substituting it in wherever I see an x. And we want to make sure both sides equal out to the same thing. So I get 30 over 5 plus 4 equals 45 minus 35. 30 divided by 5 is 6. 45 minus 35 is 10. And 6 plus 4 is 10. So both sides equal out to 10. I know I did it right. So I want you to reflect on how you've done with this video and rate yourself. Give yourself a thumbs down if you're having trouble solving algebraic equations. Finger pointed if you need some more practice, and a thumbs up if you can solve these algebraic equations. You don't need any more help or practice.